I'm going to begin with Lothar, then I'm going to talk to you, and then we can talk about the brain and genetics. Is that sequence okay?
Sounds great.
So Lothar, we first met in Sweden, in the same room where the Nobel Prize is given out.
Yes.
And you came up to me during a break, and you said, this table is held together by something. Remind me of what you said.
Yes, actually, it happened because you had a wonderful lecture, and you started out by saying, there's stuff, and it's hard, and then there's a realm of potentiality, and that doesn't consist of matter. And so then there was a break, and you left, and it was also, a big place to stand.
Can everybody hear him?
Can you hear?
Okay.
Can you hear? Is this louder?
Little louder.
Okay. Is
Put
the
mic a little
microphone?
closer.
Huh?
Put the mic a little closer.
Can I do
It's
the
okay,
mic?
it's okay. Just speak a little bit louder. That's
Okay, I speak a little louder. So, Dr. Chopra came back, and he was sitting there, and I walked up and I waved at him, and he kind of looked at me with a little bit suspicion because he didn't know what I wanted to do. But you did come, and I said, it's very interesting you talked about potentiality and matter, but ordinary material things, they are really empty of matter, most of it, and filled with potentiality. And you said, well, how do you mean? And I said, well, it's like this. 99.99% of the mass of an atom is in its nucleus. And 10,000 times more of the space of a nucleus is empty. Yes, there are electrons in there, but they are not particles. They don't have units of matter or energy. They are forms. They are potentiality. If we could take all the nuclei of all the atoms on this globe and stick them together, they would fill a football field. The rest is empty. And you said, wow, when I come back, I'll give you my microphone, I want you to say the same thing so that everybody hears it. And I said, no, we are not going to do that.
Well, we ended up with a book. So let's get this clear. Irrespective of the various schools of, quantum mechanics, observer, let's forget that. But basically what you're saying fundamentally is that what we call a particle has units of mass and energy. You can in some way measure units of mass and energy. But when you leave it alone, or when it's not interacting with other stuff,
it becomes a wave.
It becomes a wave. And the wave has no units of mass and energy. Something which can weigh and has units of mass and energy disappears into something that's actually nothing, because it has no energy or no mass in traditional terms. So what is it? And you said?
It's potentiality.
It's potentiality.
And even in addition, important, actually it happens in an electron diffraction instrument. It's a very ordinary thing. An electron enters an instrument like this, it becomes a wave. As a wave, it has lost its matter. It doesn't have a position in space. It cannot be an empirical thing anymore. It has made a transition into a non-empirical part of the world. And that is very important for many things you said in your nice lecture today. There is a part of the world we cannot see. We have to generalize. It doesn't consist of things, but of forms. The forms are non-material. They are patterns of information. Information is usually meant for a mind. So the idea evolves, there's a cosmic background and it's conscious. And in our consciousness, it appears in this world. And actually, as Carl Gustav Jung thought, the appearance of consciousness in our mind and in things may be the same thing. That's what he thought.
I think Freeman Dyson said that too, that from the subatomic particle to the galaxies,
Yes.
it's all pervasive, it's everywhere, and there's nowhere where it's not.
So,
The
if I may
potential form.
add a possible, very important addition. Evolution is a process of not adapting bodies to the environment, but adapting our mind to increasingly complex forms in the cosmic potentiality. When we get adapted to forms, we automatically adapt it to the environment, because both the environment and the forms inside, they come out of the same realm of forms. So I think evolution is really the development of mind, not of bodies.
As with this afternoon's workshop, I think you may remember I mentioned that the evolution of species is actually the evolution of forms of consciousness. So Lothar, physical chemists, talking about quantum mechanics, potential forms becoming actual forms, and going back and forth. Death is a return to the formless, and birth is back again into form from the formless. And I mentioned Tagore earlier, Rabindranath Tagore, in one of his poems in Gitanjali says, "In this playhouse of infinite forms, I have got sight of him that is formless, and so my life has been blessed." If you have not got sight of him that is formless, then your life is still waiting to be blessed. So I moved to Menas. Menas, we just spoke about form and formless. I remember you telling me once that a cubic centimeter of space, empty space here, cubic centimeter, has enough mass energy to create this universe about 3 times over.
Way more, yes.
Way more.
Way more.
You get that, guys? Okay? The space here has enough mass energy, and I'm not making this up. This is a real physicist. Okay? Okay? You can call me a pseudoscientist. Okay? But this guy is a real physicist, quantum physicist, and he's saying a cubic centimeter of space here, empty space, has more than enough mass energy
To create the universe many times.
to create the universe. And here's this infinite space around us. So the potential for so many universes right here now. So in of course, Kashmir Shaivism and Vedanta, the space is also called Chitakash.
Chitakash,
Chitakash.
the great ether. Yeah, the great...
This great space is not empty, it's consciousness. So if you were to turn your attention right now to the space between us, you can't escape it. It's around you, it's in you, it's going through all of you, and it's not only space, but it's Chitta Akash. So
It's dynamically active consciousness.
it's dynamically active consciousness around us, in us, everywhere.
Everywhere.
And the universe is bubbling out from it.
Out of this quantum vacuum, countless universes come out. They get sustained, and they get reabsorbed back into universal consciousness. How long? Forever. How many? Probably infinite universes.
So what about this Big Bang thing? From what you're telling me, the Big Bang is happening right now.
The Big Bang is happening at every moment of space and time, under our very eyes, in the vacuum of space at the Planck level. The Big Bang is just one of countless universes that came out, and it's going to get reabsorbed. Now, where cosmologists have gone a little bit too far is they say this Big Bang is everything there is. Actually, probably it's just one of the breaths of Brahman, the Absolute. So right now we're witnessing the expansion phase, and probably there's going to be a contraction phase.
But the universe that is emerging right now, this second, as
From the
we
vacuum,
speak,
from
from
the
the
vacuum
vacuum,
space.
is not the universe that we were all experiencing when we came into this room. So it's a new universe.
Every moment of space and time.
And the only reason it looks the same is memory?
So the strange thing, as you were saying before in this afternoon and just a little while ago, the strange thing is, how does the universe persist? What is the persistence if the vacuum of space-time, the Planck level, gets recreated all the time? So it must be in some sort of universal awareness field, the Akashic field, as you said, the great ether of consciousness, where things, like the cloud, where things get recorded.
As potential forms.
Potential forms. And in fact, in the Copenhagen interpretation that you mentioned before, everything is potential, and it is only when the observation takes place that a particular thing that we call an event appearing as a particle takes on a specific form, and we say, oh, do you see? It's out there. Now, what the brain does, and we'll hear from our friend here, Rudy, in a little bit, what the brain, the human mind does, I should say more than the brain, is it fills in the blanks. Because the mind likes continuity. We don't like discontinuities. If we like discontinuities, say, well, I don't really exist right now. I keep popping up every second. Yeah. So the mind says, no, this is nonsense. But actually, that's what it is. Quantum theory says that. That's the case. So the mind draws in the dots. So when we observe something, say, I close my eyes, Deepak is there. I open my eyes, Deepak is there. But when I close my eyes, I'm not really sure that you're there. You, of course,
but he is, or somebody
but of course
else.
you are sure that you are there. So by inference over and over again, you say, well, okay, he's there even when I'm not observing. So Einstein, a famous point that he made, a hyperbole because he wanted to make the point, because he was frustrated with quantum theory. He said, do you really believe that when nobody's observing the moon is not there? We don't know. We presume it is because we draw the dots.
Yeah, but again, if there's only one observer,
there's only one observer.
Then all the different modes of observation are species-specific perceptual artifacts, in fact.
Exactly.
You know, because just like there's one electricity right now in my phone and in this machine and in the computer, it's differentiating into different forms. And so the one observer differentiates into species-specific observers in multiple modes.
Probably infinite number of observers and observed objects. What you said about there's only one observer is actually very, very deep, and you heard it here. It is the one and only possibility, because everything else, if you try to have a large number of observers, then you get into recursion. You get into infinite loops that you cannot get out. So ultimately, there must be only one observer, and that is that.
Tattvamasi.
Tattvamasi.
One more thing, you know, so he mentioned, Minas, that the universe is a discontinuity. Everything is a discontinuity. I hope you get that. It's going on and off, okay? At Planck speed or whatever speed, right?
Speed of light.
Speed of light. It's going on and off. And the only reason we experience continuity is that there's memory, and it's happening so fast. It's like watching a movie, you know, with a series of still frames, and you move the reel fast enough, you see a movie, but it's interrupted, right?
It's quantized
So when
information.
you disappear and then you come back, you come as Menas, not as a hippopotamus. Is that because of memory?
Memory in the collective, but in fact, the quantum theory says that I could come back as a hippopotamus.
That's right.
Small probability, but it is
Yeah,
possible.
but it's the memory that conditions the collapse
It is the memory.
into a probability amplitude.
Yeah, and of course, where is that memory?
In the field.
In the field. And what is there? Nothing but the field.
Well,
Tattvamasi.
it's a non-empirical part of the world.
It's a non-empirical part of the
Non-empirical part
world.
of the
So right here now we are at odds with all of science, because science says empirical measurement, right?
Right.
But you're saying the most of the universe is non-empirical.
Right. And
Well,
it's the essential part.
It is
non-empirical.
it is the particular interpretation of science. I would say that the science we're trying to build, the science of the observer, or the science of qualia, the mechanics of qualia, is in fact probably the right science. Going back to Newton, Newton liked to use the word natural philosophy. I think we are all natural philosophers. I prefer that term because we are philosophers and we're dealing with the nature. That is science, what we call science. But we're also doing philosophy, of course, of the metaphysics, and that's also philosophy.
Let's go to Rudy. So I met Rudy after, how many years ago was that, Rudy? 3 years ago now? 4?
Yeah, 3.
3. So there's this conference called TED Med. It's the TED conference for people in the medical field. And Rudy just given this extraordinary talk on Alzheimer's. In case you don't know, Rudy was the first person to describe a disease-related gene for Huntington's chorea. And since then, he's described over 100 genes. Actually, more than that. Every time I talk to him, he's discovered a gene. You know, he's got it. So, you know, and he had given this brilliant talk, and we both were in the men's room, and you know, doing our thing. And I turned to Rudy and I said, Rudy, are genes verbs or nouns? And I swear to God, I thought that Rudy stopped doing what he was doing. And he said, let's go outside. Okay? And then we started talking about karma and genes and many things like that. And ended up with our wonderful book, Super Brain, and now we're doing Super Genes. And so Rudy, let's start with just that. Is the brain a noun or a verb?
Well, the brain allows you to navigate the mind. So in essence, the brain is always moving through the mind and is taking these stills that are in pure awareness or pure consciousness and allowing you to create this movie that is life. And because you can remember the frames that came before, that leads to the continuity that allows us to have self, or at least the illusion of self.
So the brain is constantly in motion like everything else.
Yes.
It's not a fixed thing. It's an activity.
Yeah, you can picture the brain like a projector, like light, and it's finding frames and feeding them to you. So it's projecting the movie of your life from stills that exist in a infinite potentiality of just pure awareness. When that awareness takes on attention and focus, then there's consciousness. If you've had an anesthetic or you're deep asleep, we say it's unconscious. There's still awareness, but without attention, there's not consciousness. So it's
An object of experience.
right.
So I remember then, you know, we kind of started corresponding, and then you had a conference at Harvard with over 100 geneticists. And I called you on the phone.
I think that was a neuroscience conference.
Neuroscience, and I called you on the phone, and I said, you called me, said, where is memory in the brain? What was the conclusion of that?
Well, we were talking about the fact, you know, we can come up with how memories are recorded in the brain, how events are consolidated into memories, and how to recall memories and associate them together. One memory triggers memory of another thing. But what we don't know is where the heck is that JPEG of your mom's face? Where's the feeling of the first time you were in love? How's that stored in the brain? Where does that exist? So our brain allows us to access it, to experience it, record it, consolidate it, place it in relative to our lives associated with other events, and recall those events back. And like Manas was saying very correctly, our memories just involve really just a few stills. We fill in the rest, and we fill in the rest differently each time depending on our mood, our perspective, and what triggers the memory.
In fact, every act of perception is a snapshot that's created from memory.
They are. I mean, the best model is a model of stills, where the brain is the verb, the brain is the active part, navigating the stills and lighting them up, but not always the same way every time.
So let me ask you something. Mauricio, I can ask you, what did you have for lunch this afternoon?
Actually, I didn't have lunch. I didn't have lunch, but I had a salad, yes, a bite of salad.
Where's that memory before I asked him the question?
The salad?
Yeah.
Let's not get graphic.
It's a great salad in the sky, you know.
If I
don't
went
know.
into his neural networks, would I find somewhere it says salad?
No, that's the thing, is that nobody can tell you that. So at that meeting, I was asking neuroscientists, you know, where are memories stored? And they say, well, in the brain. They have to use a lot of hands for this. well, where in the brain? You know, and like all the neurons get together and the synapses get together and they form the memory. I'm like, well, how? Where is it?
Well, there is
You know,
switches on
is it
and
the
off.
protein, the fat, the water? You know, how does that happen? How does it encode this picture of my mother's face I can recall whenever I want? And, well, you know, we'll know someday, but it's in there. It's just the way the synapses form. And every answer is the same, and it always involves a massive. I mean, everybody becomes Italian. They're all, you know, like me, all using my hands, right? All these proper Anglo scientists suddenly become Italians, and you know, it's in there. So the fact is, we don't know.
Now, do you remember, you have an interesting, I asked you this morning, you have an Italian accent.
Yeah,
You remember-
vaguely.
We have a lot of Italians here.
You
today.
remember
some
the
Greeks.
house you lived in?
And Greek.
You remember the house you lived in when you were a teenager?
Yes, I absolutely remember the
Can you
house.
see the picture?
Yes, I can see the picture.
First of all, where was the picture before I asked him, and where is the picture now that he's seeing it?
Now, wait, let me show you the answer. It's somewhere in the brain.
You know, it's in there. It's
You will
in there in
appear
the
one day.
synapses.
Yeah, you will get it one
As
day.
long as you use your fingers, you're always right.
You know, so people say, where do we go when we die? And the answer seems to be where that salad was before I asked him the question. Okay? Or where that picture of the house was before I asked him the question. At least that's what the Vedanta says. The Vedanta says your memories are not in your brain. They appear in your brain when the potential memory, which is called the sanskara, the wave collapses and then you have the image. But before you do it, it's everywhere, non-local, in the Akashic field. A potential form, would you say?
Is it possible that the universe becomes conscious in us and gets memories through us? Just getting to the point where you can ask such a question.
But we are the universe. I mean,
Pardon?
our universe is entirely specific to our nervous system. It's created.
No, I mean now the part of the universe, physical part, but the non-visible part that consists of forms
The empirical forms.
and consciousness.
So the empirical form that is called memory or sanskara, it's recycling as the mind, the body, and this world.
Right. Jung's memory field could be the same as the field of forms, of quantum forms, non-empirical forms that exist in the universe. And Jung actually believed in something like this, that both our thoughts and the things outside come out of the same source.
Mr. Chopra, there is a comment that's directly related to all this and all the conversations you've been having is what memory lies in the potential of consciousness that is inside every single atom within our body.
Exactly. That's why we said it's the potential field, the possibility field, which is the Akashic field, which is everywhere and nowhere at the same time. It's non-local. It localizes through intentionality. Now, what is so interesting, and we've talked about this, is that even though it does localize at this universe, this is the remembering of the universe. Remembering. It's the what in the Vedanta, this is all this struggling to learn when we simply have to remember. There's nothing to learn, you just have to remember, which is Shruti or Smriti. Smriti is the word in Sanskrit for potential forms of memory, and Shruti is you hear it in consciousness, and there it is. But it does so through very precise computations, doesn't it? The constants. tell us everywhere. You say it's a huge embarrassment for science.
It's a huge embarrassment for science today, and we keep it under the carpet, so to speak, because the universe is extremely fine-tuned. To one part in 10 to the 50, to one part, and actually to one part to the 120 power. There is no number of things in the universe that is as big as 1 followed by 120 zeros. So the universe is extremely finely tuned, and the embarrassment is that is it just random? And the usual approach of science is that it is all random, that somehow you keep flipping the coin over and over again. You've heard the expression, if you put a monkey in front of the old days typewriter, now it's a laptop, you know, and the monkey starts. After 10 to 35 years, it will give you Shakespeare. That's not how Shakespeare wrote Hamlet, right? It's not, this is really absurd. This is not how the universe operates. It goes straight to the most optimal path, probably driven by quantum biology very rapidly. And if anything, the quantum computers will show us is indeed how this happens very, very fast. So the mystery is, if it is all random, how come everything is so finely tuned? So the usual answer under the carpet is, well, we just happen to be in the one right universe where everything is so perfect that we are here. This is more or less called the multiverse. I don't want to knock the multiverse. In fact, infinite consciousness probably creates infinite universes. That's not the point. But if you want to say that this particular universe happens to be the right one and the rest of them are irrelevant, then I would submit to you, ladies and gentlemen, this is not science. It's metaphysics of the worst kind.
And yesterday, go ahead.
The same passion for randomness is in evolution.
Yeah,
In other words, it's absolutely forbidden to believe
Absolutely.
that evolution follows some purpose.
Yeah.
Like, for
We're
example,
going to come to that.
yeah, like what if evolution has the purpose to develop minds that can understand the world? It's absolutely,
So
It's
Deepak,
forbidden.
you mentioned the memory, and this is, I just wrote up my memory, something else. They say that if there is a scene, whatever that may be, or if there is something that is not right, everything is right in the universe, it's forgetfulness, forgetting who we really are. So let's say the following. The inanimate, which is the quanta, are now reminding the animate what the animate has forgotten. So actually, it is the inanimate quanta that remind us that we are the animate.
What seems to be random from the outside is a creative process from the inside. They're
Exactly.
complementarities.
Complementary.
We spoke about this, Rudy, because the prevailing dogma, as Lothar said, is evolution is random mutations and then natural selections. So before the natural selection, which is just what is preponderant, will replicate, but prior to that, it's totally random. And what's your view on that?
Well, I think the notion, I mean, biology today with big data and really looking at networks and systems is telling us that the notion that everything is random is going to become extinct. That, you know, that was a pun. But, you know, but the idea is that, yeah. But the idea is that in biology, the purpose and the design, so to speak, comes from the fact that there's always self-organization. It's a recursive system. So when I study a gene for Alzheimer's, a gene will make a protein. So that gene has created a protein. That protein will now do many different things. But in the end, somehow, either directly or indirectly, that protein will come back to control the gene. If A creates B, B must control A. You don't get away with anything. So you get these feedback loops everywhere. So anytime there's interaction at all, at any level, it's not random because You're getting a self-organizing system, and in consciousness, we can consider ourselves as just very high-ordered assemblies of consciousness with lots of density of information that's come together. 90% of us is bacteria. We're this incredibly harmonious colony of bacteria together with human cells, living harmoniously, self-organizing all the time. Okay? As this continues, yes, it has more of the appearance of purpose than randomness, because interaction is not random. When you're building sophisticated systems like humans, starting with bacteria.
Self-organized, purposive, recurrent, sentient, differentiating with precision.
Complementary.
Complementarity is all part of the evolutionary
Even
process.
gene mutations, Darwin was wrong. They're not just random. We now know that when new mutations occur, there's a mechanism that has to do with the experiences you had in life.
And
So-
also, it didn't happen in small steps, it went in big steps.
That's right. So you have a certain experience in life, and this would change your gene activity. For gene activity to change because of an experience, the structure of the DNA and how it's folded changes. Now certain areas of the DNA are exposed that weren't exposed before and become vulnerable to mutation. So that's not random. The mutations are occurring in certain spots because the DNA has been exposed because you had a certain experience in life. That's not random.
About,
You want to say
yeah,
something?
about About 2 or 3 billion years ago, there were some bacteria, archaea bacteria on this world. They became under stress with the growing concentration of oxygen in the air. So they accepted viruses into their own bodies. And they accepted two kinds. Some accepted virus that can breathe oxygen, and they became the basis for the evolution of animals. And others accepted into their body life forms that could produce oxygen. They became a system evolved, not something in competition, which is also, non-Darwinian.
Right. Our own human cells took in a bacterium, and now in our cells, the way we get energy from an organelle of the cell called mitochondria, the mitochondria has its own genome and started as a bacterium living in our cell. We're the ultimate, product of harmonious colonization.
I saw this cartoon film. You realize I love cartoons. And this film, there was an experiment where there's a cat in a box, a transparent glass box, and there's a vacuum, and the cat dies. In the other box, there's a plant, a house plant, and it's also in a vacuum and dies. And then they put the cat and the plant in the same box, and they both live. Okay, because now they're supporting each other through carbon dioxide and oxygen, and they're becoming mutually interdependent. But we're saying the whole entire ecosystem is like that. Just a few final questions, and then we'll wrap it up. As we're speaking right now, are we activating genes in the neurons of our audience?
Well, we're activating neurochemicals, we're changing neurochemical distribution, we're rewiring networks. The brain is highly plastic.
Speaking of,
So synapses are being rewired, neural networks are being rewired. And for some of the things we've said where there's been a common theme with repetition, we are also inducing new genetic activity. In doing so, you're changing the structure of DNA, and we may be causing some very odd mutations right now.
so what you're saying is, it's very profound, but what you're saying is information gives rise to form at a very fundamental level. Information, it's becoming form.
Yeah.
And if somebody is filming us, and I see that, and let's say this is on the internet and somebody is kind of clicking in Africa, are we changing their genes in
If
Africa?
the information is there, then we're changing their activities.
So that, in other words, our genes are interdependent.
Absolutely. Information is everywhere.
And information is becoming denser and more complex with
And
self-organization.
because they contain because there are mitochondria and the microbiome, the entire evolution of the cosmos is, the karma of the cosmos, so to speak, is encoded in these genes, and we are changing it as we evolve and influencing it right now through not only communication but through neural networks and information
Yeah,
technology.
if you think about the beauty in the system, you have a certain set of genes and a certain behavior that was to some extent predisposed by those genes. And you've done certain things in your life, right? So now you have a kid, and that kid gets your genes. And all of a sudden, everything you've done to others, you get back to you from your kid, because those same genes come back to get you. So genes provide the ultimate instant karma through having 3 kids.
Okay, so I think we're close to closing. So just let's look at this alphabet of life. I remember, when President Clinton in the year 2000 in the White House announced, "Oh, we've deciphered the language with which God created life," and a lot of excitement at that time. 23,000 genes. Let's study them. We'll have a one-to-one correspondence of various diseases. We can, now conquer these diseases because we know exactly what gene is coding for what. But now we come 10 years later and the promise wasn't fulfilled because you say that only 5% of disease-related genes are fully penetrant. Please explain that.
Well, for most of the common age-related diseases, Alzheimer's, heart disease, cancer, diabetes, stroke, that if you look at the genetic defects that are involved for each of these, only 5% of them guarantee the disease. The other 95% that are involved actually involve susceptibility, predisposition, and it's genes working together with each other and with the environment. So it's just a lot more complex.
But
than we
influenced
thought.
by our thoughts, influenced by our emotions, influenced by the environment, right?
Yeah, we're changing our gene activity. Your mind will change your gene activity. Your perspective, your attitude will change your gene activity. So it doesn't matter only what genes you inherited and the sequence of the DNA, but the activity of those genes matter just as much.
A lot of people actually don't know what DNA is, deoxyribonucleic acid. So what's the alphabet? What is the alphabet?
Well, okay, so each base of the DNA would be like a letter in the alphabet.
And basically it's a 4-letter cryptographic code
Right.
for all of life, right?
Right.
4 letters.
Yeah.
If that's the alphabet, then what's the word?
So a gene would be like a word, but in the, but only maybe 3% of our genome are genes. The rest is all the other stuff that helps regulate it. So you would have the base as the letter, the gene as the word.
And the body is the story.
Well, the genome itself is a story that's still being written all the time due to mutations that occur along the way. So the genome is the story.
Who's writing the story?
Manasseh's writing the story. I never knew.
Who's writing the story?
The one
Finally
observer.
we know.
The one observer.
The
And
one observer.
And the word, ultimately, what in fact we're doing collectively in evolution is to experience ourselves as I am. That really is the ultimate word.
And so many stories.
So consciousness is writing
Conscious writing the story.
the story through the genome. That's beautiful.
Deepak, we are moving into a planetary era right now. Very rapidly, we're moving to planetary awareness. The next phase of evolution, maybe 100, 200 years in the future, there will be a galactic awareness. From the planetary to the galactic. It's going to happen very fast because of information is being channeled through qualia. And in fact, our question back to Rudy, if our experiences shape the genes, right? How they form, et cetera, it will be an interesting experiment in terms of qualia science. What types of qualia are more,
Evolutionary.
effective? And exactly, they guide evolution. Is it feelings? Is it thoughts? Is it?
I remember that night that President Clinton announced, I was in actually Barcelona, And I got a call from CNN, Larry King, that they wanted me to be on the Larry King show. And so I had to drive, whatever, somebody took me to some place in Barcelona at 2 o'clock in the morning, because 6 hours ahead of wherever, New York. And there was the director of the NIH, Francis Collins, was there, and many other people, you know, they were talking about this amazing discovery, the entire genome, which of course the promise hasn't been fulfilled, because that time we didn't know about epigenetics and the influences of the environment, of consciousness, all of that was not there, right?
Plus, remember, it cost $2 billion for the first human genome, and now we get human genomes done for $2,000 each. So we've only seen a mass production of whole genome sequence data that's reaching a threshold level to figure out what's going on just over the last couple of years.
But that's true, but the point still is, it's not so much the genome, but the activity of
Right.
the genome, right?
So it's the genes themselves and the variations in those genes and the activity of those genes that's related to those variations. So up till now, we really couldn't see all the variations that mattered because we weren't able to sequence the whole genome. It was too expensive. Remember, it started at $2 billion. Now that you can get one done for $2,000, we just got 2,000 of them done. You know, it was still $4 million to do that. But with that information, now you can see the variants themselves, all the different bases that are different, and really start correlating that with the activity of those genes, and then ask which ones promote health, which ones promote disease. But that's only really been possible at this level for the last year or two. So that's why the promise has taken so long.
So to continue with that story, Larry King at the end of the show asked everybody on the panel, it was like this, I was in Barcelona, but everybody else was in the studio. So, Dr. Collins, what's going to happen? Well, we'll cure Alzheimer's, and we'll have cure for cancer, and we'll have cloning and artificial limbs and whatever, replacement of body parts. So and so, what do you think is going to happen? He repeated the same thing. And so I was there in Barcelona. I says, Deepak, what do you have to say? I'm the only fringe guy in the group, you know. So I said, I don't know what's going to happen in 10 years, but ask me about 50 years. So he said, what's going to happen in 50 years? I said, we'll take Larry King's genome, we'll use robotics, and we'll seed Larry King across intergalactic space. And using the dust of stars. And so he looks at the panel and he says, is he kidding? And the guy from the NIH, I think it was Collins, he said, no, it's theoretically possible. So then the whole thing finishes, and Larry calls me in Barcelona, just as I'm leaving the studio. He says, my brain is hurting. Could I actually be in all these places at the same time? I said, yeah, but they'll all be different people.
That's it.
Okay, that's true, isn't it? For the identical twins have exactly the same genes, right?
If you take the same exact embryo, and that embryo it develops in two totally different women, you're going to get two different children.
But even their personalities and their experiences, 23 years later, different parts of their genome will be active.
There'll be a lot of alike. They're identical twins, but the fact is that in the womb, the experiences of the mother changing her chemistry, the mother's chemistry is then actually affecting gene activity, not the genes themselves, but the activity of those genes in the developing embryo. So depending on the mother and her experience and her body chemistry, you're going to have a different embryo because of the effects on gene activity in one mother versus another with the same embryo.
And the effect can go 2 generations, I'm told.
It can just keep going. It's basically saying that a lot of who we are comes not just from the sequence of the DNA, but where we developed and what that gene activity was while we were developing as just a few cells.
Anything else, Lothar?
Well, one point is interesting to conclude this part. If there is a part of the world we cannot see, non-empirical, it means science cannot describe what the world is like. That is Scandal.
And it's most of the universe.
Yeah, the important part of it.
The greatest finding of modern science today, in the last 20 years, is the discovery of non-locality. And now, through quantum theory, it is clear to us that these inanimate, quote-unquote, inanimate objects remind us of our own non-locality. It's an amazing fact, because if you think about it, we are instantly, not with speed of light, are correlated with everything else. And this is what quantum theory says. This is an amazing fact of nature. It came from science. But again, most scientists don't want to follow that result of science, because immediately it leads you to consciousness. Immediately.
Rudy?
Well, as a scientist, I think science has its role, but the important thing to do when you do science is to not just be a reductionist. That, as scientists, we're trained just to measure things, and that empirically, what we're really doing when we say something's empirical is we're combining what's already been measured in science. The problem in science is that we always tend to try to reduce things down to the smallest parts, thinking that's going to get us closer to the truth. But I'm actually encouraged by the fact that, at least in my own field, and I think in both neuroscience and genetics, we're more interested now in systems, in networks, in self-organization, and emerging systems within genes within the brain. So rather than trying to make things, whittle things down to the smallest part, we're thinking, what does the big system look like? What are the interactions? How is it organized? And how is it emerging as a new self-organizing genome or brain all the time? So I have some optimism that science will hopefully take a better route because of that.
Next level,
Yeah.
I was trying to think how does science, or can science give us a true religious experience? And the elements of a true religious or spiritual experience are, number one, transcendence, for which science would have to go beyond reductionism. Number two, the Platonic values that emerge from that experience: truth, goodness, beauty, evolution, interconnectedness, love, compassion, joy, empathy. As you see this amazing display of inseparability. Three, loss of the fear of death, because if you're non-local, then you don't really die. You return to potential before you become actual. Four, epistemic humility. It's too complicated. You can only feel humble, and the true scientist can only feel humble. And finally, deep reverence for existence, because it seems like if by existence we mean all that exists, then everything is conscious.
See, in science, what do? We develop models, because our whole universe is basically the model provided for us by our brain, right? I mean, brain, 3 pounds of Jell-O sitting in the dark in pitch silence, and it's saying, okay, here's your world.
And
thank you.
I know how that's done.
Just
how these electrochemicals create the experience of a three-dimensional reality in space and time.
Could it be inspired by the non-empirical world? And that's how it is doing it.
Right. And you mentioned Plato. The teacher of Plato was Socrates.
That's right.
The greatest philosopher of antiquity. And he said, one thing I know is I don't know anything.
Okay, with that we'll end. Thank you very much.